Hey guys, welcome back to my channel. This is Varun Tahin. So in the last session where we have worked with Seaborn library, we saw how simple plots helps in univariate and bivariate analysis. Today we are going to continue on bivariate plots and see pairwise relationship and also see how do we work with plots when dealing with categorical data. So let's start. Now talking of plotting the pairwise relationships, you will find it helpful to plot the pairwise relationships between multiple numeric variables. For example, here we have taken the prices of some of the popular cryptocurrencies such as Bitcoin, Litecoin, Ethereum, Monero, Neo, Quantum and Ripple, and you can download this dataset from my GitHub repository, for which I will give the link in the description also for you guys. So when you click here, it will redirect you to this GitHub page where you can download this by just clicking on this download button and then going to your directory where you are running this notebook and unzipping that just like this. So you will get this crypto data folder here. Inside it you will have all these CSVs. Now the crypto enthusiast would know that the prices of these currencies will vary with each other. So if Bitcoin goes up, the others will likely follow. Now let's say that you want to trade in some of the currencies given a set of currencies. Okay, so how will you decide when and which one to buy and sell? So in that case, it will be helpful to analyze the past data and identify some trends in these currencies. So each of these currencies data is stored in this separate CSV file. So let's load them first. So I'll just go ahead and load the NumPy, Pandas and Seaborn libraries and then load the CSV and see each of the data sets. So I'm just seeing two data sets for now. So you can observe that the columns are same in both of the data set, but the data obviously will be different because these are different cryptocurrencies. Now we would like to join each of these data set into a single data frame, but you can observe here that the columns are same in each of the data set. So what we'll do is we will put a suffix with the column name so that the joins are easy. So let's do that. So I'll say btc dot columns equals to btc dot columns dot map and we'll say lambda x str x plus underscore btc. So I'm just suffixing underscore each of the elements after these columns. Okay, so likewise we will do it for every column. Now when you execute this, you will find that each of these data sets will have the changed columns now. Okay, so we'll see head and you will find that the suffix of respective columns have been added in each of the columns. So now we have to find for a particular date how well the cryptocurrency was doing. So in order to do that, we will have to merge the data frames. So we will do an inner join taking dates in both of the data frames as respective columns on which joins are performed. So here I am doing the merge of two of the data frames at one time. So I am taking BTC and Ether and doing the join and then taking that merge and then doing the join with LTC. And you can see here the names of the columns have changed. So that is why I am doing left on and right on, and the merge is inner. So here we have given inner, and the final data frame is the crypto data frame where every data set will be present. Now let's execute it and see the final data frame. So here you will have all the data set present. Obviously you won't see all the columns because the columns are many. So you can give different attributes here if you want all the columns and all the rows. That we'll see later. But for now we will try and subset only the closing prices column for plotting. So we will take these closing columns of each of the basic cryptocurrencies and we will plot it. So I will say currency equals to crypto and I will subset it with the column names. Okay. Now and let's execute this and see the head. If I check this, so it will give the result with all the closing columns so that we are able to compare each of the closing prices of each of the cryptocurrencies. Okay, now we will do a pairwise scatter plots. So since that we have multiple numeric variables, sns.pairplot is a good choice to plot all of them in one figure. So I'll say sns.pairplot and give currency here and do plt dot show. Okay, so this will take some time to execute. So when the result comes, it will show a lot of pair plots here comparing each of the cryptocurrencies closing prices. So you can observe the correlation between the currencies, whether it is linear or it is not at all relating to each other. So like there are some columns which are basically linear, which are closing ET and closing QT. You can see obviously the relation is linear. So if one cryptocurrency closing price goes up, the other also goes up. So likewise you can see the relationship for others also. So we can also observe the correlation between the currencies using df.corr, that is correlation. Okay, so let's try and do that. So I'll say cur.corr and then I will round off it to 3 decimal places. Okay, so here this data frame is a correlation matrix of cryptocurrencies. Now we'll try and find some important relationship between the currencies, and we notice that quantum and ethereum are highly correlated with 0.79. That is, if one goes up the other goes up, if one goes down the other also goes down. Okay, that is 79%. So there is another plot also which is called as heat maps, which is also used to visualize the correlation matrix. So for this I need to have some bigger plots, so I'll just define the figure first with a fixed size of 10,8. Okay, and then I will say sns dot heat map and pass in that matrix with color coding of YLGNBU. Okay, so this is yellow, green and blue, and then I will say annotation as true. So I will let you know what all this means. I'll say plt.show. So when I execute it, you will find that it is quite intuitive and it has plotted the correlation matrix with color codings as well as the figures. So this annotation is particularly for printing the figures also inside the boxes. Now the dark blue boxes show the most correlated currencies, especially the Ethereum Quantum, which is 0.79, you can observe here, and Monero and LTC. So this is represented here. Also Neo and BTC you can see 0.73, that is 73%. So these are highly correlated ones. You are seeing one here because these are cross referenced by the column itself. You can see here that close QT is compared with close QT, so it will obviously give us high correlation because the figures will be same. So you need to just ignore this and see other columns. And please note that this data is from specific time period only. So thus from risk minimization point of view, you should not invest in these pair of cryptocurrencies, since if one goes down the other is likely to go down as well. Okay, but yes, if one goes up the other will also go up, so in that case you will be lucky, but that will happen very few point of time. So this is only for a particular period of time this happened. So you should invest in varied cryptocurrencies where you are seeing a relation of inverse, so that if one goes down also the other will pace up and it will minimize your losses. So now that we have seen how to plot the numeric data, we will now explore how to plot the categorical variables as well. So often the distributions reveal new information when you plot them across categorical variables. So in this session we will plot the distribution of data across categorical variables and also plot aggregate or summary statistics across the categorical variables. So for this purpose I am using our global sales data which we used before also, and which I have loaded in the datasets folder inside my GitHub repository. So I will also give this link in the description. So right now I am just loading different data frames from the different CSV, and then I will basically draw some box plots and show you how data is categorized in a beautiful format. Now we had created simple box plots such as the one shown below also previously, And now let's plot some multiple box plot and see what they can tell us about the distribution of variables across the categories. So let's say that we want to compare the distribution of sales of various product categories. So let's first merge the product data into main data frame. I will say df equals to pd dot merge, and I'll take market df comma product df and say inner join on product id. Okay, so you will find in both of these data frames product id is common, so I'm doing an inner join. So now I will say df dot head. Okay, so here the data frames will be merged, and now we can create a box plot of the variable across various product categories. Okay, so let me do that. I'll say sns dot box plot, and what I'll take is product category, and at y-axis I'll take sales and data as df. Okay, and let me convert this to log scale. So I'll do plt dot y scale for better readability. I'm doing this. Okay, so we have done this previously also, guys, remember. So I'll do plt dot show. Now here you will observe that this tells you that the sales of office supplies are on an average lower than the other two categories, and the sales of technology and furniture categories seems much better. So note that each order can have multiple units of product sold, so sales being higher or lower may be due to the price of the unit or the number of units. Now let's see the box plot of product categories versus profit. So I'll do the same thing here as well. Okay, just copy this, and instead of sales I will say profit. Okay, and do a plt dot show. So here also the profit has clearly some outliers, you can see here in the technology segment, due to which the box plot are unreadable. So let's remove some extreme values from profit for the purpose of visualization and then try replotting it. Okay, so I'll do df equals to df, and then I will subset it. Okay, profit is less than 1000. Okay, this is for the purpose of removing that outlier. Okay, and then df dot profit, so I'll keep in brackets, is greater than minus 1000. Okay, so this we will do, then it will remove obviously this outlier. Then I'll do SNS of this box plot again. Okay, so now you can see that through the category technology that has better sales number than others. Okay, but you might have observed that it is also the one where the most loss making transaction happen. So we have seen that we have removed the outliers, okay, in all the categories starting from 1000 profit upwards and starting from minus 1000 downwards. Okay, so we have removed all these outliers and we have created these box plot, but it does not give us a clear picture or whether this particular segment is making some losses or not. So for that we will plot the box plot again, but this time we will create a subplot on sales and profit and do that. So like we have done previously, we will first adjust the figure size. So I'll say fig size equals to 10,8. Okay, this will be in circular brackets, and then we will create the subplot. So I'll say plt dot subplot, and as I have two columns, that is for sales and profit, I will make two. So 1 2 1, that is for the first column I'm making the subplot. So for the first row, so this is SNS dot box plot x equals to product category. Okay, and y will be sales in this case. Okay, so I'll say sales, and then I'll take data as df, and then let me give it a title also. So I'll say plt dot title, so that to identify it better, and put sales here. Then do plt dot y scale log. Okay, so this is for better readability. Now let me copy this again. Okay, and this time it will be for profit, and here it will be 1 2 2 because this is coming in second column. Okay, and the same I'll give in title as well. Then at last I'll do plt dot show. Let me execute it. So here we do not require log. So when I execute it, you will notice that now that we have compared the sales and profit across the product categories, it's drilled down further. Now here you will observe that the sales of technology segments are higher and furniture is also higher, but the profit of the furniture is lower than the profit of the technology segment. So here you can do a one-to-one comparison and see and drill down further on how a particular behavior is happening. Now let's drill down further and do the same across the other categorical variable as well. So we will take customer segment, okay, and we will need to add the customer related attributes, that is dimension, to this data frame. So first merge this data frame. We have to again do df equals to pd dot merge and df comma customer underscore df and do an inner join. So we'll say inner and take on customer id. Okay, so in customer df we have customer id, actually in both we have, so that is the reason we are doing an inner join. So when I do df dot head, you will see that these two data frames are now merged, and now let's plot the box plot for the product categories across that. So for it we need again the SNS object. So SNS dot box plot x equals to this time customer segment and y is profit. Okay, and we will give the merge data frame now. So data equals to df, and we'll do plt dot show. So here it has plotted across the customer segments. Okay, so profit versus the customer segments you can observe here. Now we can also visualize the distribution across two categorical variables using hue argument. So let me show you how to do it. So I'll define a figure first. Num equals to none. Okay, so this is a larger figure, so we need a fixed size also. So this I'll keep it the standard one which we use DPI argument 80 and face color. So these all arguments you can check in the documentation part in Matplotlib and Seaborn libraries. Okay, so this is just a fancy way of defining the figure. I will just define edge color also here, equals to k. Okay, now we will specify hue for the categorical variable. So we'll say SNS dot box plot and give x equals to customer segment. So I'll just copy it from here, and then y is profit, and then hue is product category, okay, and the data is df. Then we'll plot it. So here you will clearly observe the product categories coming. So across all the customers segments, the product category technology seems to be doing fairly well here, though furniture is incurring some losses across all the segments. So now let's say that you're curious to know why a certain orders are making huge losses. Okay, so one of your hypothesis is that shipping cost is too high in some order, let's say. So you can plot derived variable in that case as well, such as shipping cost as percentage of sales amount. So let's check and do that. So now let's plot the graph for it. So I'll say sns.boxplot and take x in df product category, okay, and in y axis I'll take as we discussed, that is the percentage of sales amount. Okay, so I'll just multiply by 100 and take df of shipping cost divided by df of sales. Okay, so this will in turn give you the percentage, and it will define whether a particular category is making losses because of the shipping cost is high per sales. So I'll say plt dot y label, okay, and I'll label it so that it is clearly visible what we are doing. So I'll say 100 into shipping cost divided by sales. Okay, and then I'll just show the figure. Sorry, there's an extra bracket here. So you can clearly observe here that furniture and office supplies are having a lot of shipping cost as compared to technology. So that might be the reason of their losses. So this brings us to the end of today's session, guys. In the next session, we will be seeing how to plot aggregate values across the categories. Until then, guys, please practice the concept taught. Also, I would like you to let me know how you are finding my content. If you really liked it, please don't forget to subscribe my channel and hit the bell icon for future updates. Also, please like and share it to your fellow colleagues who are data science enthusiasts, as all this content is for free, and I hope this helps. Please take care of yourselves and your loved ones. I will meet you soon in the next session. Until then, thank you for watching and stay safe.